let's start with the decision at this point. So in this particular scenario, we're talking about calculation of the eligibility score for insurance of a car. So what you see on the screen is a decision graph. A decision graph is a way to decompose a complex decision to a smaller decision unit. So calculation of the score, as you can see at top of the screen, requires some data input. Those data inputs are pink rectangles, round rectangles around the screen. Now, the way you can read and understand this decision graph is to look at the decision graph as a way to model dependencies. So the way it works is you can say, at top of this graph, I highlight in red, to calculate the eligibility score, you need the auto eligibility and you need the driver eligibility. If you look at the driver eligibility, you can see we have age category, decisions around age category, and we have driver's recording category. And if you look at the auto eligibility decision, which is this one, you can see it is connected to another node. So it requires rating from this particular node. However, as I mentioned, decisions can be hierarchical, and this particular node has different shape and color. And what that means is this is a hierarchical decision. So you can drill down to this decision and see how the rating is working. Now, this is, again, another decision graph, and the hierarchical decision means a decision can be nested behind another node of decision and can be nested behind another node of decision. So it's a nesting of another entirely decision graph within an existing current decision graph. Now, if I go back here, again, once you model this decision, you can see you don't need to talk about anything other than a decision. You don't need to focus on rules. You don't need to focus so much on the structure of the data and anything. This can be a very easy way to understand how the decision is made to calculate eligibility score, right? Now, if you drill down to any of these nodes, they are either connected to a decision logic, i.e. can be a predictive model from PMML or rule-driven model from a type of business rules modeling, or can be connected to a orchestration model which simulates, for example, another way of modeling decisions using more complex process flow model, or can be connected to another decision graph, which is the hierarchical decision concept. Now, if we go to the risk rating, what you're going to see is this has two other sub-decision units. To calculate the rating, we have theft category and we have occupant injury category. If now we drill down to occupant injury rating, you can see something similar to Excel. This is not by accident, this is by design, and that's the reason it's simple and easy to use FlexRule, because you can leverage your existing knowledge. If you know how the Excel works, you can definitely create and manage and deploy rules using decision table. So in a decision table, green columns are condition, pink column is an action. You can have as many as condition and as many as action that you want. In this particular case, let me select a row and tell you how that translates to a rule. This row that I selected says if the car has driver's airbag because the value is true, and has passenger airbag because value is true, and doesn't have a side panel because this is false, then occupant injury rating is low. So selecting a row in a decision table will construct a rule based on conditions, green column, and actions, pink color. There are other ways of modeling business rules. If I open this one, what you're going to see is an editor that allows you to write rules. This type of rule modeling is called natural language, and the reason is you can build your business glossary and business terminologies. You can establish a ubiquitous language in your domain, i.e. insurance, and then you can use them to build your business rules. And we call it natural language because you naturally can read through it. This highlighted section is called rule number 1, R1, and it says, when car is convertible, then theft rating is high. You can see it's very easy to understand for everyone, and it doesn't require any programming languages. Even building these types of rules is easy because it is guided with the suggestion box that you can select, and it provides the value for what you selected, and you can select the options that is valid for that particular scenario. So it has a context about the rules and about what is going to happen in specific scenario. And if I close it, you can see we're back to a sub-decision graph. And if I close that, you can see we're back to the actual main decision graph that we started. And similarly, in every node, you can drill down and you can see different nodes doing different things using decision graph or using rules, or even if I select a node here, you can see you can have a predictive model imported from your PMML. Your data scientist team build an algorithm, statistical algorithm, regression, classification, whatever it is, and you can import it here as part of the decision graph and integrate that, that predictive model as part of this decision-making scenario. Now, that's all good in terms of designing decisions, but how is it different from doing it in Visio or Paint or whatever you're doing on the whiteboard? The big difference is if you do it in FlexRule, these are not just graphical, beautiful, easy to understand models. They are executable. You can go live and start debugging them and start understanding how they behave step by step. You're in control. So in this particular scenario, we have 3 data inputs: driver information, car information, and client segmentation. So if I drill down to the type of the information we need, you can see another model that specifies how the car information is structured, or in the other instance, how the driver information is structured. And you can see there are some of them, it's very small, but are highlighted here. There are some icon identifier behind them that it says this particular field of information within car or within driver information has some constraints. So you can manage your constraint about the information, if they are required, if they're mandatory, if they're not, if they're within certain range and all of that. And you can import, for example, JSON schema to build that automatically, or you can build it simply with drag and drop and setting values of these fields. Once all of that is set up, let's go and have a look at how the debug simulation mode works. Now you can see yellow arrow, yellow highlighting here, which I highlighted with the red rectangle. Now this yellow arrow, yellow highlighting is the step of execution, meaning that we're about to execute this particular decision. And I say decision because this is linked to another decision graph. Now, you are in control if you want to see all the details of that, or you want to skip this one and you want to go to the next one. So I go here and I say, yes, I want to go to the details. You can see it navigates with you. You are in full control how detailed you want to go. So I want to execute the next one. I say, okay, yes, let's execute this one. You can see now it goes to natural language. It executes all the rules one by one. And if you see the yellow arrow, yellow highlighting, that means this particular rule number 2, which is saying price greater than 45,000, match the criteria of the input car, and it's been executed. We go one by one again. We are back to the decision graph, and it's going to ask us, do you want us to execute this specific decision, potential occupant injury category? Do you want to see the details? Okay, yes, why not? Let's go to the details of that. Now you can see again, the yellow arrow highlighting comes with you, and I'll show you how you can skip it in a minute, because if you have a complex decision, you're probably running too many of those decision rules. You don't want to run all of them every time. You want to find where the issue is. Actually, you can put a breakpoint here saying, I want to run it and stop at this particular rule and see what the problem is this. But we didn't do that, so let's run it. And now we are back to this stage, and we are back to the decision, the main decision graph. Now we can go to the next one. We don't want to see the details. And if I stop this, you can see now, based on this decision graph and the rules we had, we calculated the eligibility. Now, what is interesting, when I talk about the decision orchestration, I didn't mean the decision graph. Don't get confused. The decision graph, or if you're using DMN, decision requirement diagram, is a simplified version of the decision graph. They're not decision orchestration. They are decision modeling tools that allows you to model a decision. Now, decision orchestration is what you see on the screen. So you might need to have a database connectivity. So you can drag and drop a database here and connect to a database, or you might need to send a notification after the premium is calculated to a particular request. So you can drag and drop, and you can build this within all the tooling that you have in your place to build the orchestration around the decisions. Where are those decisions? These nodes that I highlighted are those decisions. The rest are orchestration around those decisions. So I changed this, I closed this, and I reopen it to see the original one. Now you can see in this decision orchestration model, we have a start point, and we have multiple termination node and successful end nodes. Start with the start node, which is this green circle. And at the beginning, we validate the input information. How do you validate them? It's very simple. We already defined the structure of the data that we need. So we just pass the information to here, and it does the validation for us. And once that is valid, data coming, we go to determine the eligibility score. If we drill down to this, this is another decision graph. I didn't go through this, but if you look at this in the middle, this is a decision eligibility score that we already discussed. So I close a couple of them, and I go back to this decision graph. The other thing is, now when you do a decision orchestration, now you can combine the data from different data sources. You can transform the data to the shape and form that you require for decision making, that is in the context of decision automation. And then what you can pass them to the decision graph to create the decision outcome, and then it returns back to your decision orchestration. Now you made that decision, you can integrate that into your organization systems and processes, post it to information system for the record, communicate it to the client, record it in the database, pass it for an audit. So the orchestration is a very significant piece in the decision automation and management practice. Thank you, everyone.